For more than a century, engineers have been trying to give metal wings the grace of birds. At first, they copied nature. Symmetry, balance, simplicity. But as jets climbed faster and higher, nature stopped being enough. The air changed, the rules changed, and the shapes of flight began to look strange. Some worked brilliantly, others barely flew at all, and a few were so far ahead of their time that people simply gave up on them. This is the story of those forgotten designs, the deltas, the swing wings, and the twin booms, and why, decades later, they might be coming back. Through the 1950s, speed was everything. The world had entered a Cold War, and whoever reached Mach 2 first would control the sky. Straight wings, perfect for slow flight, were now a liability. So designers began to draw triangles, short, sharp, and strong. The delta wing was born. It looked simple, but it was revolutionary. With its wide surface and thin leading edge, it could handle the shock waves that formed near the speed of sound. France built the Mirage 3. Britain created the Vulcan. America tried the Convair F-102 and F-106. For the first time, aircraft could fly higher, faster, and cleaner than anyone thought possible. At Mach 2, it was perfect. The Mirage 3 could climb at nearly 50,000 feet per minute, and its stability at high altitude made it nearly untouchable. But that triangle came with a price. At low speed, the same design that sliced the air now trapped it. Lift dropped, drag increased, and landings became dangerous. Pilots of early deltas described it as flying a brick with wings. They came in fast, flared late, and prayed they had enough runway left. Still, the delta wing became a symbol of progress, pure geometry against a cold sky. It inspired the Concorde, the sleek white dart that carried passengers faster than the Earth's rotation. But fuel was expensive, noise restrictions multiplied, and the dream faded. The triangle had touched the edge of perfection and learned how fragile perfection can be. As engineers searched for a new miracle shape, another idea took hold. What if a jet didn't have to choose between slow and fast? What if it could change its shape in midair? That was the logic behind the swing wing, a variable geometry wing that could pivot backward for speed and forward for lift. The first to try was the General Dynamics F-11-1. It was powerful, heavy, and full of promise. Then came the Panavia Tornado in Europe, and finally, the legend, the F-14 Tomcat. When a Tomcat took off from a carrier deck, its wings spread wide like an eagle. Moments later, they swept back, slicing through the sky like a missile. For a while, it looked like the future had arrived. But moving parts are expensive parts. The pivots had to withstand enormous pressure. The hydraulics needed constant care, and the aircraft gained so much weight that its advantage began to disappear. A typical F-14 required over 40 maintenance hours for each flight hour. It was brilliant engineering, but inefficient reality. By the time stealth aircraft arrived, with smooth, fixed wings and computer-controlled surfaces, the swing wing felt obsolete. It was too complex for an age that valued simplicity. When the last Tomcat retired in 2006, its wings locked for the final time. It marked the end of an era, a reminder that even brilliant ideas can be crushed by practicality. But long before the triangles and the folding wings, another odd shape ruled the skies, the twin boom. In the 1940s, the Lockheed P-38 Lightning used it to deadly effect. 2 engines, 2 tails, and a central cockpit gave it strength and stability. The design worked so well that pilots called it 2 engines with 1 soul. It allowed the P-38 to fly faster and higher than any Allied fighter early in World War II. It became the first U.S. aircraft to exceed 400 miles per hour in level flight. After the war, others tried to modernize the twin boom. Britain built the de Havilland Vampire. Sweden produced the Saab 21. Transport planes like the C-119 carried soldiers and supplies between those twin tails. It was practical, balanced, and strangely elegant, until the jet engine outgrew it. Turbines needed long, clean airflow, and the twin boom, with its extra surfaces and drag, got in the way. By the 1960s, it had quietly disappeared, replaced by sleeker single fuselage designs. But if you look up today at modern drones, Predators, Reapers, or long-endurance surveillance aircraft, you'll see the twin boom again. Slimmer, lighter, and more efficient than ever. Old ideas never really die. They just wait for the right materials to make sense again. Each of these designs, Delta, Swing Wing, Twin Boom, tried to solve the same problem: how to control air that refuses to be controlled. Every breakthrough brought new trade-offs. Every success revealed a hidden flaw. The Delta mastered speed, but punished pilots. The Swing Wing adapted, but over-engineered itself. The Twin Boom balanced perfectly, until engines outgrew its frame. And yet, all three keep resurfacing in new forms. Stealth bombers like the B-2 use blended delta shapes to manage lift and radar. Experimental drones morph their wings in flight using flexible composites. Even flying cars and electric aircraft revisit twin boom layouts for efficiency. It's as if aviation can't stop returning to its misunderstood children. Today, aviation is shifting toward designs that were once only theoretical. The most promising is the blended wing body, a single smooth shape where the fuselage and wings merge into one. It produces far less drag, carries more fuel, and could cut airline emissions by nearly 30%. NASA and Airbus are already testing prototypes, and companies like JetZero plan to fly full-scale versions this decade. At the same time, flexible morphing wings are reviving the swing wing idea without heavy pivots, and twin boom layouts continue to dominate long-endurance drones. The future of flight won't be defined by new inventions, but by finally giving old ideas the technology they always needed. Today, we tend to think progress means replacing the past. But in flight, the past is often the foundation of the next revolution. Every failed idea leaves behind a piece of wisdom. A curve that worked, a balance that mattered, a lesson that engineers will rediscover when technology finally catches up. The Delta Wing showed how far geometry could take us. The Swing Wing proved that transformation is possible. The Twin Boom reminded us that balance can be beautiful. Maybe none of them were mistakes. Maybe they were previews, early glimpses of what flight could become, because the sky doesn't forget. It just waits for us to learn the same lesson again.